Types of thermocouples. Did you know that not all thermocouples are the same? From food processing to steel manufacturing, every industry uses a different type of thermocouple. But why? And which one should you choose? In this video, we'll explore the different types of thermocouples, their ranges, advantages, and real-world uses so you'll have a clear picture by the end. Hello and welcome to Yoga Thermal Guru. If you're new here, this channel is dedicated to thermocouples, RTDS, and everything about temperature measurement. Today's video is about the types of thermocouples, one of the most important topics if you're working with furnaces, labs, food processing, or even aerospace. A thermocouple works on the principle of the Seebeck effect. When two dissimilar metals are joined, they generate a voltage depending on the temperature. Now, depending on which metals are used, thermocouples are classified into different types. K, J, T, A, N, R, S, and B has its own temperature range, accuracy, stability, and cost. Choosing the wrong one can cause inaccurate readings or even sensor failure. Base metal thermocouples, most common. Type K, chromo-aluminal, most widely used. Range, -200 degrees Celsius to 1260 degrees Celsius. Pros, wide range, affordable, durable in oxidizing environments. Cons, not great in reducing or sulfur environments. Example, used in gas turbines, diesel engines, kilns, and furnaces. Type J, iron, constant in range, -40 degrees Celsius to 750 degrees Celsius. Pros, strong signal, good for vacuum applications. Cons, shorter lifespan at high temps due to iron oxidation. Probe metal, used in plastics, packaging, and old heating systems. Type T, copper, constant in range, -200 degrees Celsius to 350 degrees Celsius. Pros, extremely accurate at low temps. Stable, doesn't corrode easily. Example, perfect for food industry, medical labs, and cryogenic applications. Type E, chrome, constant in range, -200 degrees Celsius to 900 degrees Celsius. Pros, highest output voltage among base metal thermocouples. Excellent for very low temperatures. Example, used in cryogenics, environmental testing chambers, and nuclear applications. Type N, microsil missile, range, -200 degrees Celsius to 1300 degrees Celsius. Pros, most stable than Type K at high temps. Resistant to oxidation, example, aerospace, petrochemical plants, and high temperature research. Noble metal, thermocouples, high temp. Joe, expensive. Type R, platinum rhodium, range, 0 degrees Celsius to 1600 degrees Celsius. Pros, very stable, accurate, long-lasting. Example, used in glass manufacturing, refineries, and laboratories. Type S, platinum rhodium, similar to Type R, range, 0 degrees Celsius to 1600 degrees Celsius. Very precise and stable. Example, used in scientific labs, calibration, and pharmaceutical industries. Type E, platinum rhodium, range, 600 degrees Celsius to 1700 degrees Celsius. Pros, can withstand the highest temperatures. Stable even in extreme environments. Example, steel plants, cement kilns, glass furnaces. Quick comparison for better understanding. Here's a quick way to remember them. Type K, king of general purpose use. Type J, just for medium temperature, old systems. Type T, tiny temp range but very accurate at low temps. Type E, extra voltage, rate for low temps. Type N, next gen. K, more stable. Type R, S, B, royal or special thermocouples for extreme high temp labs and industries. So, depending on your industry, food, glass, steel, power generation, or aerospace, there's a thermocouple type that fits best. Tips on choosing the right thermocouple. When selecting a thermocouple, keep these 3 points in mind. Temperature range, how hot or cold does your process get? And is it oxidizing, reducing, or corrosive? Accuracy versus cost. Noble metal thermocouples are precise but very expensive, while K or J types are cheaper and widely available. Always match the thermocouple type with your application to get reliable and long-lasting performance. That's all about the types of thermocouples, from general industrial sensors to high-precision platinum ones. If you enjoyed this explanation, hit that like button, share this video, and subscribe to Yoga Thermal Guru for more easy explanations on temperature sensors and measurement systems. And let me know in the comments which thermocouple type have you used in your work or studies. In our next video, we are going to explore what a cold junction and a hot junction are in a thermocouple.